What's up guys, Richard here, and today I wanted to talk about the most ambitious project I worked on. Basically, it was a 3D engine with multiplayer support. Now visually, this is not a very impressive project. It's actually very basic visually. Okay, so if you look here, there's a bunch of files. First up, we've got gameengine.lib. That is the game engine itself. Then we've got server and client. These are basically implementations of the game engine lib. One is a client, one is a server. It's an example of how it would work. And then I've got this converter. So the converter, that's a separate system I developed. Basically what it does is it takes in OBJ files, object files, and then converts them to binary files, which my engine can then use. It lowers the size of the OBJ file massively, but most importantly, it speeds up loading times insanely. Without using this converter that I built, basically OBJ files could take up to 30 seconds to load if you're loading in a model that has hundreds of thousands of tries. Now, I wanted to get that down as low as possible because most games nowadays obviously have hundreds of thousands of tries, and that's why I developed that. Anyway, let's have a look at what it is. So it's a very basic system on the surface here. We've got our, I'm going to open up the server and the client, and basically with the server, what IP address. So I'm just going to give it the loopback IP address. Okay, and then I'm going to do the same thing with the client. Okay, now the client, you'll notice it will say, what is your name? So I'll just be John. And then I can go, hello there. And then that will appear on the server side. And then I can go, okay, are you ready? Yes, I'm ready, so let's start the game. Now this is going to freak out. The reason it's going to freak out is because both of them are pulling the mouse at the same time, and it's just causing them to wig out. But what you're essentially looking at is there's a 3D model in space. You see when I closed off one, then it suddenly started working again, and that box represents the other the user. So it could be the server or it could be the client. So here I'm looking through the client's window, so that would be the server. And basically, as the server moves around, the client moves around as well. But it only works on two computers well because they're both trying to steal the mouse position and also pull the mouse to the center, etc. Okay, so I'm going to close those off. Now let's actually look what it's built from. So we have the game engine here. So I'm going to start with this. And I'll probably just work my way down and explain my thought processes with each part. So let's go into the assets. So what we've got here is our global asset manager, and I've got these basically asset managers. So if I open up the asset manager, so we've got an asset manager which handles specific types of assets. It's a templated class, as you can see here. So I could say, hey, you're an asset manager and you're going to manage meshes, or hey, you're an asset manager and you're going to manage materials, and it does not matter to the asset manager. It goes, cool, I'll manage those moving forward. And the global asset manager basically just takes a whole heap of them and gives them different templates and says, okay, this is my shader, this is my mesh, this is my blah blah blah. And the whole point behind it is just so you can easily go, okay, I want to get the texture asset manager, I want to get the model asset manager, without having to type in these really long complex strings. Just makes things a lot easier. And it also handles the cleanups and the initializations, etc. Okay, so that's pretty much basic there. I'm going to open up each one of these folders because they're all basically at the same level. We've got our model asset. The model asset basically encapsulates the mesh asset along with the material. So if you have a look in here, we've got the mesh and the material are both part of the model. So the model is basically the container and the material mesh sit under it. And basically, if you have a look at the mesh, all that does is it has its own functionality to load in from that. Do you remember the converter I was speaking about? It loads in those files, and they're called RD files for Richard Delmore. So it basically loads those in and then just assigns them with an OpenGL. And that's something I forgot to mention. This entire system, it works using OpenGL. Okay, so, and this is just the function right here, the load static mesh, and as you can see, it just reads in the binary file. It's really quite simple. Nothing too advanced right there. Okay, now we have a look at the material asset, and you'll see the material asset actually consists of a diffuse texture, a specular texture, a shininess value, and a shader. So basically, for those who don't know, diffuse is basically your standard color, your specular is your shine, And the shininess values there is just to basically state how shiny you want something to be, like how much it pulls on that specular part of the texture. And then the shader itself is basically the actual shader that the OpenGL will use, the code for it, the GLSL code. So I can say, hey, I want a material that's going to use this shader and these textures, and I want it to assign it to all these model instances. That's the benefit of using this type of system. And it's basically just got to bind and unbind, which is all automatically called. Okay, then you've got your texture asset. What this does is it basically just loads in a texture. So we've got initialized texture right here. If I come in here, you'll see that I am using STBI image loader. Basically, I did not have time to write my own JPEG loader or PNG loader, so I just stole this open source loader that you can get and just use that to pull in the texture. There's a couple of if defines in here, which basically says don't do this if we're in debug, or if we're in release mode, just to save on resources. Basically just assigning a texture in OpenGL. That's pretty much it. Okay, the shader system. So we have our shader system, which allows it to easily send things like vectors, RGB colors, mats, samplers, all that, because OpenGL is not very friendly in that aspect, so it just makes it a lot easier for the end user. Generate shader basically just says what type of shader you want and where's the source for the shader. The source would be a file, an external file, or it could be the internal ones that come with my engine. Basically just loads them in, does some debug information, make sure it's all good, initializes it, so it takes in a vertex and a fragment shader, which is called a pixel shader in DirectX. Loads those in, basically goes through it, does a couple of checks, and then down here we've got the uninitialize, which is basically the removing from OpenGL, and the initialization, which is, this is called from here. So you see here, when you initialize the shader, it actually generates two separate shaders, one for vertex and one from fragment. Okay, so that's the material system. Then we've got our light system. The light system, I've got my own data types. I'll go over those in a minute, and transform. So basically it's just a position in space, what color is it, and you can just set it, you can get its location, get the color. It's really simple, the light system, because it's just used for the shaders. So that there is the assets. Now, before I jump into everything else, I just want to go into data types. Okay, so originally I was using GLM, which is an open source OpenGL math library. It comes with absolutely everything. It's amazing. But the problem was I wanted to build this as a library. In fact, originally I wanted to build this as a DLL. And I faced problems with DLL boundaries. Basically, I was not able to pass GLM structures, so data types between the DLL and also the end user's client without them, or their server or their client, without them having to include those individual libraries and download them, which was just causing massive headaches, and I could not find a way around it. I even changed to a lib thinking maybe that might help, but it didn't. In the end, what I did is I built my own data types. So basically, we've got our standard vertex. Now, a vertex is used for OpenGL, so it consists of a position, normal, and a texture coordinate. And then I have my vec3, which obviously is pretty much used everywhere for positioning. I've got all this functionality, did a bunch of overrides. Some of these overrides are actually not needed because you're never going to use them, but I just wrote them anyway. Got some helper functions like 2 radians to normalize it, get the world up. Those are static functions, so I can just, go vec3, colon, and whatever I want. Okay, then I've got a vec2 equivalent. The transform, so the transform is basically used for moving an object, so it's got its forward, its local, its right. In fact, I have the transform, and then I have a derived object transform, which includes additional information, because the standard transforms just position and scale, while the object transforms like, hey, you've also got forward, local, up, and right, because you normally need to keep track of that stuff. RGB is basically just for colors, as you could imagine. Got my RGB3 and then RGB4, which just includes alpha, so it's just a derived class inheritance kicking in. Quaternions, this was a headache. I still don't I don't understand the maths behind quaternions, but I got it working. I am not a quaternions expert, but the fact that I got it working made me very happy, because I built my little game test engine to be like a 3D sim in space, which means you can rotate around completely. And when you're working with Euler angles, the problem is you very quickly hit that gimbal lock and it causes so many issues, so I had to use quaternions. They were a challenge with beyond a doubt. Okay, then you've got your standard matrices. Nothing really important in here. I basically just replicated the GLM library, but made some changes, made some optimizations optimizations for my system, and that's basically it. I actually done a test against GLM, my math library versus GLM, in a release build, and mine actually performed a little bit better, which is maybe because they're using so many... I don't know why. I thought originally maybe it was to do with them using templating, but templating doesn't affect the actual runtime. Like, that all happens during the compile stage, so it can't be that. So I'm not sure what was actually causing the issues there. Okay, so let's go back up. So cameras, I got a perspective camera and a smooth mouse. I'm not going to bother the perspective camera. It's just a perspective camera. It basically has just got, well, I guess I am. You've got your perspective view matrix and stuff like that. Anyway, then you got your perspective camera controller. So you got the controller for the camera, because you could have a camera without a controller. Basically, this is just, it just takes in positions, grabs, like, is the mouse down? Are you looking left, right? Are you moving around? And basically just does all those calculations. The smooth mouse, a problem, obviously, I didn't think this was a problem when I first started developing it, but basically what happens is when you're moving the mouse around, it's totally different and very system dependent. So I needed to create a system that would allow the mouse to actually tap into Windows itself to find out what was the move rate set for that system, so that I could then apply that to my engine. And this is the parameter, I believe, right here that does this. So get the system mouse speed, usually 10 for desktop, 20 for laptop, and it basically performs a bunch of calculations based on that. Then that also grabs the delta time, which is coming from my own little time library down here using Chrono. Okay, I've got my client, and here, what is this? I'm not sure what that was, can't remember. Console, so I've got a non-blocking console. Basically, it's running on its own separate thread. It's just your IO stream, but on its own thread, in order to stop any issues there. Gone through data types. Dependencies is, okay, so you've got glue and GLFW. GLFW is the window, it's like an OpenGL open source Windows library, so you can create a window. Glue basically just links OpenGL drivers with the functionality that you'll be using. Game engine, I believe I went through most of this already, except for the networking side of things. Yes, networking. Actually, I think this here is just a doubler. There must be a problem with the project settings. I can have a look at that later. Anyway, networking side of systems. So I've got a network subsystem, which basically handles very, very low level networking calls, and this is all written using WinSocket 32. So if you have a look up here, I'm using the Windows library for that. Basically, it just handles the very basic server and client implementation of that. And you'll notice here I've got this thing called a network class. Oh, by the way, this is also on its own separate threads, because you face an issue where if you run this on the current thread you're on, what happens is it's a blocking. WinSockets, or sockets in general, is a blocking function. Like, it sits there and it blocks all processing until it receives a new call, then it actions that call, and then it blocks all new processes again. So they have to be on their own separate threads, which required the creation of the subsystem to basically pull it out and do everything that was needed there, because there's two separate while loops. Okay, so we've got the network packet. Network packet consists of a name data class, a data packet, a data type, and the socket. The socket is who you're sending to. The name is basically, as you saw, you could type your name in, so it's just a special string of specific length that can be set by the engine. We've got the data packet, which is basically this. This is actually quite a clever little struct class. If I go peek at it, you'll have a look in here. You can feed anything into this and it will store it. And it basically just stores it. So here you could feed a string in, you could feed another data packet in. You can feed in... Oh, you'll notice I'm using wchars because I wanted this to work internationally as well, because I love playing around with different languages. Data packet, data packet, data packet. You can feed in a name class, you can feed in arrays, you can feed in W strings, you can feed in vectors. So you can basically put anything in here. And the whole idea was that there would be one single network packet. And no matter what information you wanted to send, you could just feed it straight into that data packet and then send it through the network manager. Now, the network manager basically handles all the packets. So you can see here I've got some functions: server, send network packet to everyone, send network packet to everyone except this person, blah, 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 to a specific person, to a specific socket. And then what happens is when they receive packets, then they go to the network event dispatcher, which basically says, hey, I have these network packets, and you can add an event, pop an event, and basically just access them. There's the name. It's basically just my own custom string class, nothing fancy going on there. Okay, that is basically the entire system. And then obviously I've got the server and client implementations, which is not really important. It was just for testing purposes. Okay, that's pretty much it. If you're curious about how any of this works, feel free to reach out.